Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So, remember Doom? Doom was like a 3D game, but it was kind of like a, fake 3D game. So the characters were obviously not 3D. They were actually 2D sprites, but they were rendered to kind of mimic the third dimension. So essentially, as you can see in here, so we have characters that look straight at the player, and some of them are looking to the side. So obviously, what the developers had to do, they had to actually render the character at different angles, right? And then depending on the angle of the player and the angle of the entity or the character, they would actually pick a different sprite. So we're developing a kind of similar game with a similar engine, right? So you can find the source code in the description and for people in the chat, because we're streaming right now on Twitch. Right, I'm gonna put it in the chat. So let's actually open it up. So we've been developing this thing for I think a month, maybe less than a month. So we're slowly developing this entire stuff, and as you can see, we already have sprites, right? So these sort of like billboards that always face at the player, and the reason why they always face at the player is because no projection is applied to them. We just slap them on the screen. We figure out where the point in 3D is going to be projected on the screen, and just in that specific point we just slap the 2D image onto the screen, and that's why it creates this sort of effect that the the image is always rotated towards the player, right? It's an illusion actually, right? It's because we always slap it onto the screen without any projection. So we're kind of slowly moving towards adding multiplayer to this game, and that means that we need some sort of a way to represent the players in the game, right? So that means we are going to have these characters that can see each other, and they also can be at different orientations, right? So they can look at different in different directions, and we need to somehow reflect that. Right, so because we're gonna be shooting like bombs, throwing bombs, and maybe some other projectiles, and you need to be aware of the direction your enemy looking at. It's kind of important. The game has to indicate that somehow. So I actually did a quick sketch of the potential player sprite, right? So it's not finished. It's sort of like a sketch. Like I outlined how it's gonna look like. So this is how it looks like, right? So this is basically what's the player gonna look like. I think for different players, we're going to customize the color of the body, the color of the eye, and stuff like that. And I actually drew this player at different directions, right? So 8 directions. So if you play them as an animation, it feels like the player is rotating, right? So I actually drew all of that manually. So we can even do it like that. So what I want you to do today is to actually just implement a renderer that can actually pick a correct sprite of the direction based on the angle of the camera and the angle of the entity. So this is what I want to spend the time on today's stream, right? I think it's going to be interesting because I don't really know how exactly they do that. It's probably related to the angle between two vectors, between the vector of the camera and the vector of the entity, but also I think the projection of the camera also plays a role, right? So we'll see actually. I already converted this entire sprite sheet into like an actual sprite sheet. So it looks like this, but you can't really see that. So let me actually do something like white. Right, so this is a sprite sheet. Let me disable the anti-aliasing. So yeah, what is the first thing I want to do? I want to maybe create a sprite in the world that renders one of these things. So this entire thing is basically concatenated into a single image. It's called Atlas. I need an ability to actually say, okay, render the sprite, but actually this sub-image of the sprite. As far as I know right now, our engine doesn't have that ability. The only thing it can do is that you give it an image and it just renders an entire image as the sprite. So we need to be able to actually render sub-images so we can have this sort of like, entities at different angles. Right, so let's actually see how we can do that. Sounds good, sounds Gucci. Tamaguchi, as usual. Okay, let's go. So we have watch mode, which is nice. So let's go into the game TS. So all of that is written in TypeScript. So where do we render the whole thing? So we render it somewhere here. I think we need to first load the image into the asset. So we have a function create game, right? So, and in here we're gonna literally load image data, and the player, if I'm not mistaken, is located somewhere here. It's assets, images custom player.png. So let's go ahead and simply load this entire thing like so. It's a web development, right? So it's simple. Like anybody can be a web developer. It's not like we're developing an operating system or anything. It's just like, you know, websites, right? Silly little websites. So, okay, so everything seems to be compiling, and let's actually maybe open DevTools. Open DevTools, and let's take a look at the network. Did it actually load the player? Here is the player PNG. I can see it. So can I preview? Oh, there we go. It actually even shows it. Yo, look at that, like a glow and stuff like that. Fancy. Oh my god. So DevTools is trying to display everything in a fancy way. Holy shit. Anyway, right. So, and I suppose we need to add the player image. So this one has to be like this. So we're sort of decomposing it. Player image data, and we have an interface for like assets, all of the assets that we have in the game, right? So image for the key or image for the bomb and different sounds and stuff like that. So I suppose we need to have a player image data in here. Right, so here is the player image data. Okay, so after that, after we loaded the player image data, we're simply adding it into the assets. So now we do in fact have that in the assets. Do we have any compilation errors? We don't have any compilation errors. Perfect. All right. So what's the next thing we want to do? After we updated players, items, bombs, and stuff like that, I suppose we need to print, like, render a sprite. The way you render a sprite in this engine, right, in this sort of engine, is by calling the function push sprite. So let's actually find the definition. Push sprite. So the reason it's called push sprite is because you push in a sprite into the sprite pool, because they're not rendered right away. First, you're accumulating all of the sprites that you want to render, and then there's a whole pipeline going on that actually removes some of the sprites that are not visible on the screen. They're the ones that are too far away and stuff like that. Then it sorts them and so on and so forth, right? So if you want to render something, it's not really rendered right away. It's just pushed into the pool, and then that pool goes through the entire sort of like a pipeline, right? So the actual rendering of the sprites happens much later, right? It happens somewhere here, actually. So it's like a cool and sort sprites, right? So I don't remember how you pronounce cool. Is it call or cool? I don't speak English. I really apologize for that. So first you sort of like remove the ones that are not visible, then you sort them by z distance and stuff like that, and only then you kind of render them. Okay, so first you have to specify the sprite pool, right? So what we're doing here, we get the sprite pool from here. Then we have to specify the image. We do in fact have image. It's located in the assets. So the first one, like skull. Oh, okay, thank you. So this is actually very good mnemonic, like a skull. So it's a call. Okay. So it's assets, player. It's not really. Oh, it's assets are located within the game. Game assets player image data. Then we have to specify the position where it's going to be located. So let's actually put it somewhere at 0, 0, right? So as far as I know, the default arguments for X and Y are 0, 0. So if I don't provide any arguments, it's basically that. Okay, so Z is basically the height. So essentially, I think I can put 1. So that means it's going to be at the ceiling, right? Because the distance from the floor and the ceiling is actually 1. 0, that means the thing is going to be at the floor. 1 is it means it's going to be at the ceiling. So we're going to put it at the ceiling, and the size is also going to be 1, right? So it's basically going to take the whole space from the floor to the ceiling. Hopefully, we'll see how it goes. Okay, so does it compile? It seems to be compiling. Okay, so and let's see if we can see anything in there. So maybe I had to refresh. Let's actually refresh the whole thing. Oh. Right. So right now you can only have square sprites, right? And as you can see, it's actually sort of it tried to fit the entirety of the thing into like this square. And this is basically the sprite sheet. You can see the player at different angles, essentially, right? So it's an iron fence. Yeah, exactly. It's an iron fence. But it's actually the sprite sheet of all of these things. It's just like compressed into a square. So I would like to maybe put it a little bit closer to the sort of like a gateway that we have in here, right? So here we have this sort of gateway. So let me see if hot reloading still works. Does it work? Oh yeah, it still works. Okay, look at that. So maybe I can now put something like half in here. Right, so is it working? Is it working? Yeah, so it's working, it's working. So as you can see, we have hot reloading without any void. Can your void do that? I fucking think so. Right, I should stop. I should probably stop. Actually, the last time I attracted too much attention from the creator of the beat. So for my stupid memes, I really apologize for that. So I just want to say that I'm just memeing around, right? I'm just memeing around. I don't even know what is beat, honestly. I'm not the web developer, okay? I'm not the web developer. So anyway, what I want you to do, I probably need to maybe extend push sprites where I could specify, you know, how I want to cut out the image, right? So I specify the image, and then I probably could specify the rectangle, right? But the thing is, if I'm going to be specifying the rectangle, it has to be reflected within the sprite itself, right? Because we have an interface for the sprite. So interface sprite, so here is the sprite, and here we specify the pushed sprite. It has an image, which is either image data or color. It has position, z scale, and there is some intermediate data that is computed throughout the pipeline. You never really specified like any of this stuff. This is the data again that is computed throughout the pipeline. For example, the distance from the object to the player, like a normalized horizontal distance, and so on and so forth, right? So what we could do in here, we could basically say crop position, right? So basically, if we're cropping an image, where is the left upper corner of the cropping rectangle, right? So this is going to be crop position. And also we want to introduce something like crop size, right? So what's the size of the rectangle? So as you can see, we have two vectors and they represent the rectangle that we want to crop. But what's interesting is that, so what if you don't want to crop, right? So how are we going to be doing that? What we can do in here is that if you call push, right, and you don't want to crop, you just specify the crop position to be 0, 0 and crop size the size of the entire image, and there you go. You just render the entire image, right? So we can always crop it. It's just like if you don't want to crop it, just like specify the entirety of the image, right? So I guess that makes sense, right? So I guess that makes sense. So so if I do push sprite, so in here you have to specify crop position, which is going to be a vector, and a crop size, which is going to be vector. We do have push size calls throughout the code, and what we meant throughout the code is that we don't want to crop. So what I'm thinking is that maybe we could make crop position and crop size optional parameters. So, and if you don't specify any of these parameters, you just mean the entirety of the image. So when somebody calls this thing and doesn't provide crop position and crop image, we just set them to 0, 0 and the entirety of the thing. So that makes sense. So you only crop the image when you actually specify these parameters. I think it makes sense. I think it's fair. Right. So that way we don't break any of the existing code. So I think that's pretty cool. All right. So here is a very interesting thing. So the sprite pool is actually a pool. So that means it reuses the objects that you push in there, right? So essentially, if the capacity, if the size of the pool is about to become bigger than its capacity, right? So because we have items, right? So, and we don't really deallocate these items, right? So because we're programming in JavaScript, right? In a garbage collected language, we're trying to preserve the objects so the garbage collector doesn't try to, you know, collect them. So because it's It's a usual pattern in these kind of languages, right? So where you just have a pool of objects that live forever and you just reuse these objects, right? So that's what we're doing in here. So, and here we're pushing an object, and if we don't have one, and otherwise we're just reusing one of the latest one. I don't know why I separated this entire thing, honestly. I don't know why I separated. I feel like it would be better to maybe not make it an else, but actually just let it fall through in a sense. Right, I think that makes more sense. I don't really know why I did it like that. So essentially, if you're about to overflow the capacity, we just pre-allocate additional object, and after that we fall through in here and we just use that new object that we pre-allocated. That only makes sense, I think. That only makes sense. So the only thing we do in here is just like we're cloning the position. We don't really have to clone it, right? So if we just create it, then down there, when it falls through, it's going to be set to a new position anyway, so we don't really have to do that. So the only thing we need to add in here is probably crop position, right? So let's create a new vector 2, and here we're going to have the crop size, right? So we just pre-allocated all of these things. Okay, this one is really interesting. I don't really like how huge of an expression this is. It just points at the last thing. Can we just factor it out into something like index, or maybe last? All right, so this is going to be last. So this is the last thing in here. Yeah, there we go. So that's a little bit better, I think. That's a little bit better. All right. So essentially, the easiest thing would be, in our case, honestly, just take the crop position and just simply set the crop position that we were provided in here, right? So we were provided crop position and then crop size, right? So that would be the easiest thing, but it's not that easy because this thing can be missing, right? Because before we didn't even have these parameters, so we kind of need to maintain backward compatibility with existing code. So crop position might be missing. It might be missing. So, okay, so let's do a very simple thing. If crop position, so what does it say? What it can be equal to? Is it going to be equal to, right, so, oh, it's actually copy, right. Okay, so what it can be equal to undefined or null. Oh, okay, so if it's optional, it could be equal to undefined. So we have to check for the undefined. So if this thing is equal to undefined, what we have to do instead of copying it is to set to 0, 0, right? So that's what we have to do in here. So let's just do set 0, 0. There we go. So if you provided crop position, we're going to use that crop position. If you didn't provide it, we're going to just set it to 0, 0, basically the left upper corner, right? So makes sense. Very easy. Very, very easy. So in case of the crop size, this one is rather interesting. So if you did in fact provide it, you just copy it. But what if you didn't provide it? If crop size is equal to undefined, we don't really know what we want to do in here. So if we didn't provide the crop size, the obvious thing that you want to set in here, right? The obvious thing that you want to set in here is actually the entirety of the image, probably, right? So we have an image, and this is where we're starting to have a little bit of a problem. Image is not necessarily an image. It could be a solid color, right? So sometimes you want to create a sprite that is just solid color, and it does make sense because, for example, the particles, when the bomb blows up, they're solid colors, believe it or not. As you can see, they're in fact solid colors, right? So this is one of the options that you can have in here. And how can you set the size of the solid color? It doesn't have a size. That's the thing. It doesn't have a size. Right, so if image was image, we could have just done something like image, maybe width and image height. So maybe one of the things we have to do before doing any of that stuff is to check that the image that was provided by the user is actually image data and not the color. Right, so let's do it like this. If image instance of, what kind of Java is that? Like, why JavaScript has instance of operate? I mean, it also has the word Java in the name, which is kind of sad. But at the same time, it doesn't really look like Java. Like, what the fuck is going on with the branding of this language, honestly? Is it Java related or not Java related? If it, okay, it's not Java related, why the fuck does it have instance of then? It's like the most Java thing I've ever seen in my entire life. So yeah, where's your god now? If JavaScript is not related to Java, what the fuck is instance of? What the fuck is instance? Oh, the real name is Emacs script. Yeah, okay, so that explains it. Emacs script. I think this is a new way to piss off web developers. Like, yo, from now on, I'm gonna call ECMAScript Emacs script. Yes. So, anyway, instance of image data. All right. So what do we have in here? So this is the image data. But if it's color, cropping this thing kind of becomes meaningless, almost. Right, it kind of becomes meaningless. If it's just a color, we can just set crop position and crop size to 0, essentially. Right. It was inspired by Java trying to pull Java applet devs. Yeah, I guess so. From what I heard, it was basically Java was like a buzzword at the time, so they were just trying to capitalize on that. So it's like these days creating a new language and calling it Rust script, right? So it was just like, you know, the hype thing of the day. So it's basically the same thing. Anyway, so even though that language would be not related to Rust, right? You still call it Rust script to capitalize on all of the hyped up devs. So I suppose if image is just a color, we probably want to set crop position and crop size to 0. So let's actually zero them out. Rust script, yeah, exactly. So 0, 0, and this one is going to be crop size. Okay, so that makes sense, I suppose. If it's image, we just do some shenanigans. If it's not image, we just set both of them to 0, and that works out. Here's an interesting thing. I don't think it is correct to set the crop size to the entirety of the image. Right, it makes sense if the crop position is set to 0, 0. But what if the user of this function set the crop position, but didn't set the crop size? Think about that. Think about that for a second. Actually, I think I'm gonna start, I don't even have to start my paint. I can just use this thing. Wait a second, 256. Right, imagine that you have this kind of image. Can I have a rectangle of some sort? Can I just create? Yo, I can have a rectangle. Okay, that's pretty cool. So now imagine. You set the position somewhere here, right? So here is the position, but you didn't set the crop size. What it will do, it will essentially set the size to the entirety of this image. So you will have a doubled image that goes outside. So what you have to set is actually you have to cut out that the parts that overflow that image. Right, I think that's what you have to do. So essentially we set the entirety of the image. But then we want to kind of subtract the position in here. So we can just like take the crop position and we're just subtracting this entire thing. I think that makes sense. Yeah, so image size minus crop position, exactly. So that's what we're doing in here. Right, and with our current vector 2 implementation, we can quite easily do that. Right, so because sub actually modifies this thing in place. So this is image size, crop size, blah, blah, blah. All right. So it's defined, undefined. All right, that's pretty cool. I didn't want to do that. So we still compiling, which is nice, right? So it is super nice. Let me see. We now want to. It actually moves really fast, surprisingly. I don't know why. What changed? I don't know. So, what is the size of a single frame in the player? I don't really know. What's the size of this entire thing? Oh, okay, I see. I think it's 55 by 55. Okay, so I don't really know why I choose 55 by 55. But that's what it is. Okay, so crop position. Crop position is going to be, let's say, 0, 0, right? And crop size is going to be actually 55 by 55, right? So let's actually set it to 55 by 55. Is it going to work? Is it going to twerk? Or I think it got a kind of stuck. Ah, I see. Yeah, so we introduced all of these new parameters like crop position and crop size, but we didn't actually use them in render sprites, right? So after we sorted out all of the sprites, right, we need to actually use all of that stuff. Okay, so here's, if the sprite is image data, we do one thing. If it's color, we do another thing. So if it's color, we don't have to crop anything. We just basically ignore it here. Okay, this one is interesting. So here is the position of this entire thing. Yeah, okay, so we are trying to figure out tx and ty, which are the coordinates on the sprite sheet. So by doing this thing, by taking this value and dividing it by sprite size, we're finding the normalized x from 0 to 1, and then we're denormalizing it by multiplying by, I suppose, the entirety of the size. So what I think we need to do in here is actually use crop size x and crop size. So we have to use cropped size in here. Crop size, crop y. All right, so that we're using the size of the actual sub image in here. And in here, then we are trying to find the point on the sprite sheet. So, and the point on the sprite sheet actually have to be offset by the crop position. So what we have to do in here is add sprite crop position x, not x, y, right? So we're offsetting this entire thing, and then plus sprite crop position y. Do we have to do anything else in here? Okay, so then we have x and y. What is x and y? X and y are going from the boundaries, and the boundaries, these are the screen boundaries, right? So they have nothing to do with actually the sprite stuff. So I guess that's it. I don't really see anything else in here. So I don't actually see anything else in here. So I think it's fine. So the compile seems to be Yo, what the fuck? Yo, it's looking at that. Holy shit! It's so ominous. By the way, if you refresh it, like imagine like going. It's so fucking ominous. Look at that. Motherfucker is so fucking ominous. I was just like, what the fuck? It's a horror game. What the fuck? You can't see. You can't see. Okay. Alright. The fuck? Scary. Anyway, so what you can do, actually, we can now maybe pick a different frame. Since we're rendering sub-images now, right, so we're rendering sub-images, we can maybe even offset some of the things. Right, so here is the crop size, and here is the position. So that means if I do something like 55, 0, it's going to be the next frame. Is it going to be the next frame? Isn't going to be the next frame. I don't know. Did I save it? I think I'm pretty sure I saved it. I guess it didn't pick up. No, it didn't freaking pick up. What the fuck? So that's bizarre. Let me refresh the compilation. Maybe it didn't compile. Maybe it didn't compile properly. All right, so it's compiling. It is compiling. Okay, so now if I refresh, nah, it's still this one. It's kind of bizarre. What's up with that? What's up with that? Did I do a fucky wucky? I don't remember doing any fucky wucky in here. So this is that, and this is... Ah, I see. I already found an error. It's supposed to be X. Okay. All right. Yeah, look at that. Look at that. Look at that. It's now looking to the side. That's pretty cool. Now, I can probably multiply by 2, so that will be the next frame now. And now it's rotated. So we can multiply by 3. So essentially this is the index of the frame, right? We can even factor it out to like index. right? And our job essentially is going to be to map two vectors, the vector of the player and the vector of the entity where the entity is looking, into this index so we can display it on the screen. Right, so that's basically the job, the task at hand. What's interesting is that maybe we can actually animate this entire thing over time, right? Because we do have time, we pass the time, we even have just a global time. So what if I take the time and maybe I essentially take a mode over 8, right? So because we have 8 different frames, right? So if we mod it like 8 and then floor it, we basically get a different index over time. So that means it's going to be rotating. Right, so it's rotating, right? So we're just like animating the index and it just switches the frames and stuff. So that's actually pretty cool. That's actually pretty cool. So can we make it faster? Can I multiply it by 2? Will it make it faster if I multiply by 2? It's kind of bizarre. Okay, so it is actually faster. Yeah. So what about... I didn't want to do that. What about 16 now? Right, so... Look at him go! Look at him fucking go! So it's actually pretty cool. That's actually pretty cool. I really like that. It's really fucking funny. So okay, so let's actually bring back the maybe something like 0. Let's actually bring back something like 0. So okay, there we go. So now we need to figure out how the fuck can we even do that? How the fuck can we even do that? But maybe I want to make a small break, right? So I think the time has come for me to make a cup of tea. So it's not really super hot anymore, right? And that means I can actually drink hot tea now and get some caffeine into my system. So I think I would like to take that opportunity, right, and make a small break. So what do you guys think? Sprite flavored tea? No, it's gonna be just like green tea, right? So tea is back. Tea is back. Okay. All right, we're back. So let's try to figure out what exactly we need to do. Maybe we'll need to draw a little bit before, you know, we can start coding. Okay. So let's imagine that you have a player. So I need to pick an appropriate brush before I can do all of that stuff. So here you are. Maybe I want to actually do something like this. And come on, you can do that. Show me the... Okay, there we go. So this is the player. So this is the player. And the player, let's just assume that the player looking up. Right, so the player looking up. And then we have an enemy or some other entity. Right, let's call it an enemy. Like so. And the enemy is looking down. Right, the enemy is looking down. If you put these two vectors side by side. All right, so this is the player's vector, right? This is the player's vector. It's looking up. And this is the enemy's vector. It's looking down. So that means that at the angle of 180 degrees, you have to show the first frame of the sprite sheet. Right, because that's the first frame of the sprite sheet. It's looking at us. So that way, that means that I'm looking upwards and they're looking in the opposite direction. So it means at 180 degrees, we have to show the first one. So then, essentially, we are having another vector in here, which is probably looking like this. And that means we have a smaller degree in here. So it's 180 minus 45, right? So because we have 8 directions in here, right? So we have 8 directions. Then it's going to be 90. So that means it's going to be 90 in here and so on and so forth. So the way to figure out what index we have to show is by computing the angle between the two vectors, between the vector of the player and vector of the enemy. So let me see. If we take a look at the player, Where is the player? So this is the game. Within the game we have a player, and within the player you have a, okay, direction is an angle, right? So direction is an angle. So we already have an angle of the player. We need to introduce the angle of the entity, right? So let's say entity angle, right? And let's say that it's going to point maybe at 0 currently, right? So it is pointing at 0. And essentially, we need to somehow create a function, right? A function that accepts game player direction and entity angle. So, well, I mean, for the consistency, for the sake of consistency, let's actually call it entity direction, right? So we need to create a function that, given these two angles, gives us the index within that sprite sheet. And that is going to be basically the goal of the stream, right? So somehow we need to do that. The most annoying part is that what's the value of the angle? You can try to subtract one angle from another one, right? But what if the player's vector is just like minus 720 degrees, right? What if it's that? So you kind of have to normalize the vector first. I think we had a similar problem when I was developing my game in Ada, right? So we even had a function to sort of compute the, you have two angles, right? So how you find the angle between them or something like that. So let me see what we can do in here, right? So maybe we could actually display all of that stuff in the minimap, right? So as you can see here, we're just rendering the FPS. Can I add some text in here? So first of all, here is the minimap, right? So we're in do we need a minimap? I'm not sure if we really care about the minimap. So what is going on in here? So let me put 0, like so. So here is the 0. Is it going to work? Okay, so that seems to be working. Now, I want to render some text. We already have this text in here. So maybe I can do fill text. So this is going to be something like test. Can I put this stuff in here? Can you render this thing, please, for me? It's taking some time. It's lagging like fucking crazy, mate. So this is because the context is a part of the display. Okay. Okay, so it still doesn't work because... so, come on. Let's open DevTools and see what's going on here. So it's obviously crashed, but why did it crash? It's not defined. That's bizarre because... Here it is. Didn't not refresh. Okay, so it just didn't refresh. Fuck's sake. Okay, so here's the test. Okay, I want to put it maybe somewhere down there, like 200. Yep, there we go. So now I have a test in here. So perfect. So I have some place where I can put some debug information if I want to. So the player angle is more like game player direction, right? So this is the player angle. So here it is. Show me. Yeah, there we go. It's in rads. God damn, it's in rads. Okay, so how can I convert it to degrees? I have to divide it by the pi and multiply it by 180. So that's going to be in degrees. I'm pretty sure. So this is in degrees. So when so it could be negative. It could be pretty much negative, but it actually goes negative. Look at that. Right, so the actual value stored there when I'm rotating around is negative. You do need to normalize all of that stuff. So maybe obviously I probably want to have something like a player entity, player direction. Right, so this is going to be player direction, game player direction or something like that. So, and let's put it in here, player direction. So the first thing we want to do, Emacs, okay. So we want to do mod, but we want to mod it at math pi multiplied by 2, right? So because the full circle is 2 pi, right? So this is a 2 pi, right? And that should, now, if it compiles, please compile. Maybe. Why doesn't it compile? Okay, so it compiled. When it goes negative, it still goes negative. This is because we need to use proper mode. Wait, so I suppose, yeah. When it goes negative, it wraps around. Yeah, you need to have a proper mode in here. You can't just use the stinky mode with, with the percent and stuff like that. You need to have a proper mode. I think we had a proper mode in here somewhere. No, we even had a proper mode in multiplayer game. Right, so we even had it in a multiplayer game. So I need to pour that thing from there. Where is the client? So proper mode. It's not even in a client. I think it's part of the common stuff. So proper, yeah, there we go. This is what we need in here. So that's what we have to do in here. Look at that shit. Look at that. So this is a proper mode. I'm not sure if I want to export it from the module, but that's the thing we have to do anyway. Yeah, proper mode, like so. This is the proper mode. Okay, go. Yep. All right, so that's proper mode. If I, yeah, then now everything's fine. Now everything's fine. I don't have to worry about that. So I know that the value of that angle of the player's direction is going to be from 0 to 2 pi or 360 degrees. Doesn't really matter, right? So we're only displaying degrees, but the actual computations are happening in RAS anyway. So, okay. So now we have the entity direction. So regardless of the entity direction, we probably have to do something else in here. So I'm still thinking how I want to approach this entire thing, because where do I get this value, right? Where do I get this value? I get it from somewhere, but I mean, it doesn't really matter. So it looks like a stupid expression, right? It looks very stupid, but this is because like in the future, I'm going to be plugging in something from here, right? So I'm going to be plugging in something from here. Okay, so I have two values. One is from 0 to 2 pi, another one also from 0 to 2 pi. So now I can maybe subtract one from another, right? But the question is which one from which one I want to subtract. Right, so if I'm looking up, I'm at 90, right? I'm at 90, and I'm subtracting the bigger one, right? I'm subtracting the bigger one. So if I'm looking down, this is supposed to be 90 multiplied by 3. Right, so looking down is 180 plus 90, so it's a 270 degrees, right? So 270 degrees. So we can actually kind of try to emulate that. So math pi, right? So math pi, and I need to divide it by 2, but then I need to multiply it by 3. So something like that, yeah. So we can even do it like this. Does it make sense? Does it make sense? I think it makes sense. So that's the thing we have. And when I'm subtracting, player direction from entity direction, I get a negative value. That's the thing. Right, so let's actually maybe put A in here. Right, so put A in here. And I simply want to put A, just to see what's the difference between them. Right. So this entire thing, where is 0? Right, if I'm at 0 degrees, where exactly I'm looking at? Like, I'm not even sure. How can I figure that out? Maybe what I can do, I can set the player to look at 0. I can try to do that. So if I'm not mistaken, in the index TS, right, in the index TS, where it's not even here, but it's somewhere create game. Create game, player. Okay, so I can just specify the angle for the player. Right, that's actually pretty cool. Yeah, so I can specify the direction. I can simply put 0 in here and just see where the player is looking. All right. Please refresh. Okay. So I'm looking in kind of a weird... I see. So that means 0 is looking towards this is looking towards this wall. So if I set, yeah, okay, so this thing is already looking at 0. So if the entity looking at the wall, that means the angle is 0. So that's cool. That is very, very cool. So that means that this is 0 and the positive one, is it really positive? And the positive one, so let me find the player direction. Yeah, no, this is negative one. All right. So yeah, let's actually keep it at 0. Right, let's keep it at 0. So this is 0. So we do direction and then we have a. Okay, so let's actually do it like that. So right now we're looking at the difference between all of these things. Right, so if I'm looking right at you like that, it's actually 180. It's actually 180. Okay, that's cool. Right. So now, what if I put 2 math pi divided by 2. Almost said story, yeah, exactly. So this one is, the difference between them is 90. Okay. I need to know how this entire thing reacts. So what I'm thinking is, maybe I can create a separate program, like a test.js. Test.js. So you have a player direction and you have a player entity. So, and in all fairness, I would like them, so the player is gonna stay at some sort of thing. I think it's going to be math pi, right? So this is the player direction, and then we're going to be varying. The entity's direction. So how are we going to be varying? Let's actually iterate through the entire circle. So let's actually rotate this entire thing, but let's rotate it at very specific, intervals and stuff like that, right? So let's rotate it at very specific intervals. So let's do maybe let from 0 to 10. Maybe we can even make it equal to 10, something like that. Right, and the entity direction essentially is going to be, 2 math pi divided by 10. Maybe it makes sense to actually put, 10 into this thing. Right, into this thing. So, and then we multiply by I, right? So if I now print the entity direction, so does it rotate around, so to speak? So can I do node test.js? Okay, so it's going from 0 to 6 something something something. If I divide it by math pi, multiply 180, is going to be from 0 to 360. Okay, so that's totally fine. That is exactly what I want to do. So, and in original game code, I take the player direction, right? So I take the player direction, I subtract the entity direction, right? So subtract the entity direction. And what do I get in here? Right, so this is going to be A. Right. Right, so they do console log A. There we go. So this is the value from one to another, right? So from one to another. And for example, if I subtract 2 math pi, the entire circle, this entire thing shifts around, right? So because one of the things we have to do proper mode for 2 math pi, and this one also proper mode. entity to mathpy, like so, right? And now we don't have a proper mode, obviously, but that's fine. We can actually bring it. Proper mode, where is that? Didn't I? Yeah, here it is. Let's put it in here, right? So that's the proper mode. Still doesn't like it. Something about, oh, this is because it's not a TypeScript. It's actually JavaScript. All right. So what do we have in here? Okay. So this is the value. All right. So and now if I remove this entire thing, it still stays the same. It still stays the same. Okay, that's pretty cool. All right. So if I look, for example, so the player direction is 180, right? What if I say that it's going to be 90 degrees, right? So it's going to be 90 degrees. So it's mathpy. So we're looking up. No, it doesn't really have to be this way. So it's 180, and yeah. This is another 180. So at this point, the angle of the enemy is actually 0. We are at 180 and the enemy is at 0. So that means at this specific point, the index of the sprite sheet that we have to display to the player has to be 0. But this one is not. So this one is equal to a whole pi, which is 180, which means that we have to subtract an entire pi out of here to actually get a value from, yeah, there we go. That makes sense, I think. All right. That's actually kind of cool. All right. So, yeah. You subtracting them, and you basically, yes, you basically get this thing. But then now the angle is kind of always negative, right? The angle is always negative, which means that what you probably want to do is maybe take an absolute value, right? So you take an absolute value. It's not mathpy, it's ABS. So this is the absolute value of this entire thing. All right. And you want to probably normalize it. You probably want to divide it by, 2 mathpy. So you get the value from 0 to 1, right? So you normalize it. And then you multiply it by the amount of things you have, the amount of indices, and then you math floor it. You math floor the entire thing. So that means this is how you get, right, the actual index in here. If you know what I mean. If you know what I mean. So, yeah, we can even maybe have like 100 in here, and yeah. So that's basically the entirety of the thing. Very interesting, honestly. Very interesting. I think that's the way to go. So we can even call this is the index, actually. Can I simply copy paste this entire stuff in there? All right, so because, yeah, we already have a player index, so all of that just fits in here. All of that just fits in here, and then we just use the index. Okay, well, that's kind of bizarre. It didn't really work that well. Oh, this is because it's looking actually here. So what's the entity? Okay, so the entity direction, we don't even have to do any of that stuff in here. So we just use the player direction, and the direction of the entity has to be in here. I think it kind of worked, didn't it? It's kind of hard to tell, but not really. I feel like it has to be actually looking to the side. I think it has to be looking to the side. What if I actually add? Oh, it's went over some stuff. over some stuff. That's kind of bizarre. Like I don't know what's up with that. We're almost there, I think. Right, so there's a not test and it's complaining about missing something, log console A. Yeah, so because it's just an index. It's just an index, okay. So let's go to here. Let's go to here. So proper math entity. So let's decompose some of this stuff, right? So let's decompose some of this stuff. So it's going to be a console const a like so, const a like so. All right, so that's what we've got. So the next thing I did is actually subtracted that. What if I add math pi? So that's going to become bigger. So it kind of goes over math pi. What if I do 2 of them? So I feel like one of the things I have to do is instead of doing ABS, I should have actually done proper mode again. I think that's what I had to do. Yeah. So after I subtracted all of them, right, so that's what I had to do. This is the index now. This one is interesting. So this is the value. Let's maybe try to put this thing back in here. This is a proper mode that. So A. So this is the player direction, then the entity direction, then that, and then that. Okay. So that's the value we get. And then it goes, yeah, it goes from bigger to that one. So maybe, what if I actually, I think I have to swap them around. I think that's what was the problem. Yeah, I think that was the problem. So this is A, then this is the value from that to that. And what's funny is that we probably need to do a proper mode with the 8 because this thing can be equal to math pi. Maybe not. We'll see. So I don't think it's that important. Okay, so let me put this thing in here, and maybe that's the new index. I think that's the thing. Yeah. All right. So this is compile. It seems to be compiling. All right, it's looking in the right direction. Holy shit, I think it's working. It's looking towards the wall. It's supposed to look towards the wall. Almost. Well, okay. Man. Okay, so it makes sense. I see. This is not correct visually, but it is correct from the mathematical point, from the math that we actually calculate. Okay. Yeah. So this is the flaw in our logic. Right. It is not enough to just compare the angle between the vectors, because you can have this kind of situation. So this thing should actually look here, but it's looking to the side because of how the vectors are computed. So it's looking straight at us when we are looking straight at it. But yeah, when you look to the side, it's kind of, well, I mean, it's kind of correct in here. It's correct when you're too close to it. I feel like it has to take into account the projection. It has to. Well, this is correct actually. Look at that. Look at that. It's actually correct. Yeah, this is also correct. What the fuck? Because there is a little bit of a like a part of the eye in here. Right. So like you need to somehow take the projection into account. You kind of need to take the projection into account. So what I'm thinking is that, all right, so I have the following idea. Okay. How can you take the projection into account? I've got some tea, by the way. What if, okay, look, what if we take the position of the entity and project its feet onto the screen? So we get the point on the screen. Cool. Then we offset their position by their direction by maybe 1 or something like that, by a certain amount. And we project the new point now. We get another point on the screen. We take a vector of 2 projected points, and that vector is basically where this entire thing is looking. So that's how we can take into account the projection. So that's how we take in the account, like the projection into account. So we can try to do it like that. Interesting. All right. So maybe this is what we need to do. Maybe I need to make another break, actually. Maybe I need to make another break. But I'm not 100% sure. Direction will be added after getting the angle for rotations. What are you guys talking about? So what are you guys talking about? Can it be the angle between enemy look direction and the line between player position and the enemy position? Maybe we can try to do that. And Tiago Diniz 33, I think you need to calm down actually. So for 1 hour. There is no need to caps at me, especially when I'm, you know, doing a very difficult intellectual work while hundreds of people are watching. So before screaming at me, try to do the same. All right. While imagine somebody in the chat screaming at you as well. Just to get a sense of what exactly I'm doing on my streams. So that's an interesting idea. We could try to do that. We could try to do that. Yeah. I'm just screaming at the screen, but you can't hear it. Yeah. Rest in peace, random guy. Well, I mean, if they're a reasonable person, they will understand what I'm saying, and they will be back, but as a different person. Right. So I actually trying to think good of people, right? So maybe they just don't understand what it is to actually stream in front of hundreds of people while doing a difficult intellectual work. They maybe never experienced that. So like you need to be polite, you need to explain to them what it is, right? So that's actually kind of difficult. You need to have a full focus, right? So anyway, so and that's why I timed them out, right? So I gave them time to think about their behavior. So that's an interesting idea. So just basically, yeah, let's go ahead and do that. So we can have angle. So that means we need to take the player position, right? So Oh, we need to even, that means we need to have the entity position. Okay, so entity position. So as of right now, the entity's position is simply that, entity position. All right. So, and after that, essentially, we need to take the entity position, but we'll have to clone it. All right, so we'll have to clone it. Then we have to subtract the player position. Let's get that. And we need to take an angle. And I wonder if I even have this stuff. So vector 2. So set angle. So do we even use A10 2? No, we don't even have A10 2 anywhere. So what we can do, we can just introduce a method that takes an angle. So this is a vector 2. We have a length though, so I think it's kind of related to that. So this is an angle and gives a number, and the angle is simply A10 2 electric boogaloo. So y, x. So that's how it basically works. So for those who doesn't know, like this is how you take the angle between two, like for a certain vector. What's the angle of a certain vector? That's how you do that. So A10 2, and you have to provide y and x. So the reason why you have to do that is because actually mathematically you need to sort of like take a slope of your vector, and slope of your vector is actually y divided by x, and you take arctan of that thing, and that's how you compute a vector. But then there's a whole problem with signs going on when you are in a certain quadrant. So they introduced A10 2 to fix all of that. But you can only fix all of that if you know the specific coordinates in here. So what they did is that they forced you to actually pass the coordinates separately. Right. So, and the reason why they accept y as a first and x as a second, so then it is easier for you mechanically to switch from A10 to A10 2 and replace slash with a comma. So it's kind of weird, but this is the reason like why A10 2 is so weird, right? Because it's kind of mimicking the original thing that you want to do mathematically, but it's a new version that kind of fixes some of the problems with sign and everything, and it needs the specific coordinates, so you have to, you know, like pass it like that. So, and you can kind of like visually compare them, right? So you can kind of visually compare them. Right, so you see what I'm talking about? So it's kind of funny, actually. It's kind of funny, but nobody remembers that, all of that, right? Because everyone just automatically uses A10 2, right? So because that's a better version anyway. So I'm waiting for A10 3, where they finally fixed the order of these things. Legacy, maybe it's legacy, but this is just like actually my hypothesis why it is like that. So anyway. So this is the angle, and yeah, we can probably even just do some stuff like that. So that's I suppose, my friend, I suppose. So this is entity direction. Yeah. So we're trying to find an angle between, yeah, between these two things. Okay. Okay, so we don't use this stuff anywhere. Like, so the fact that I have A in here kind of confused me. So for a second, so I really apologize for that. So instead of player, we have to just use that, I suppose. And oh, that's annoying, chat. That is extremely annoying because that breaks all of the logic that I built up in here. That breaks all of the logic, so I have to start over because now, right, so when I'm looking, so I don't have to shift anything anymore. That's basically what we have in here, so I don't have to shift anything. I could maybe get rid of this thing. All right, so I can get rid of this thing. So here is the proper mode for entity direction. Here is the mode for this thing. So we're just subtracting this entire stuff, but then we take a mode again. Then we're renormalizing things and so on and so forth. All right, so yeah, that's about it. And we don't even need the player direction anymore because it's kind of taken into account in here. All right, so let's see if that changes anything. So I'm actually kind of curious. It's broken because 949. Oh yeah, we're trying to print this entire thing. Okay, so that's why. All right. Yeah, it's broken. It's not looking correctly at all. Though that is kind of sus, honestly. Right, so the entity is supposed to... So what if I swap them around? What if I swap them around? Right, so... Yeah, it's not correct. So I need to... So I don't... Where is it looking in? Where is it looking in? Yeah, so I need to rethink the whole thing, right? So I need to like reimagine how the angles map to specific indices and stuff like that. Like I need to reimagine that because switching to a different paradigm completely broken the entire model that I have in my head. Right, so yeah, so we probably need to make a small break. And after the small break, when I make another cup of tea, we can continue actually doing all of that. Okay. Okay, so I just realized that we don't really have to do anything much. We can just swap around how we subtract, right? So right now I'm subtracting player from the entity, so which kind of switches the direction of the vector. So we have to do the opposite from the player, and that will, or will it actually, or will it? It's kind of bizarre. So maybe it was already fine. Maybe it was already fine. So this is the entity. So this is the old code based purely on the what is it called? On the angles between the entity and the player. Right. So entity and the player, and this is what we do. So I could. I'm not sure. I think I'm doing the correct thing. So if I'm subtracting the player's position from the entity position, I'm having a vector that, yeah, so that looks towards the entity, right? So that's correct, actually. That's correct. So then I do that one, and right. So then. Afterwards, I'm subtracting 180. I'm subtracting 180. And that's exactly... Oh. And because of that, I have to actually do... Yeah, come on. I actually have to do it like that. Right, so this is entity direction. This is sort of like reminiscent of the player direction, but it's a player direction with respect to the position of the player in the entity position, right? So, and after that, we're subtracting this one to take into account some shifts and everything, because this is how we rendered the sprites. And then, right, so we're also normalizing the whole thing. Right, so that more or less corresponds to my mental model that I have in my head. Right, so hopefully. Yeah, and it's looking at us. Okay, so that's perfect. And that fixes the problem that we had. Okay, so that's nice. All right, so thank you so much person in the chat who pointed that out. Next time, please say all of that calmly. There's no need to caps at me, especially because I'm streaming for you know, hundreds of people It's already hard. I have to pay attention to a lot of things. All right, so that works. So that's actually pretty cool. I really like that. That's nice. Okay, but it's not entirely right. So there's some weird situations. Can I maybe reduce the resolution, so to speak? So this is the factor. Let's actually make it factor, maybe something like 20. Yep. Could you refresh? Yo, so the resolution is lower, but hopefully this entire thing is faster. Yo, look at that chat. Look at that chat. Isn't that a poggers? Isn't that a woggers? I think it is pretty freaking poggers. Right. I think that's pretty fucking poggers, mate. It's pretty fucking poggers. It's a bit weird that it's not entirely... Yeah, let me see. There's some fucky-wackiness going on. Not gonna lie. Fucky-wackiness. So maybe there should be some sort of an offset if we think about that. Right, if we think about that. Because... maybe I need to start my paint. Right. So because it has to be some sort of like... a range. Maybe we have to subtract like 1/8 of a pi, right? Or maybe add 1/8 of a pi, right? Because we have to kind of like, yeah, do the thing. Just a second, right? So we need to adjust for those things. Right. So where is the... It's that stuff. Right. Not really 1/8 of a pi. So 1/4 of a pi is more like 90 degrees. So it has to be... Yeah, it has to be like maybe 16 or something. So it should look that... So if we just offset the angle of the... I'm not even sure which angle should we offset. Like it doesn't really matter. It's like one of them. It's actually one of them. Let me see. So we can maybe add math pi. So so it's more like 8, right? So 1/8 of a pi. So maybe subtract or maybe add. I'm not sure which one. Which one is going to be better? Okay, so it's probably add. It has to be added. So let me see. It's honestly, it's already more like details. Yeah. No. Okay. And now if I... Yeah, now it's correct. Okay, so I'm really happy. So I think we adjusted all of these things more. Oh my god, this is actually perfect. Yeah. There we go. So that's pretty cool. So we just had to, like, you know, adjust it a little bit so it's within the ranges, if that makes any sense. I don't really know how to explain that. Yo, that's ideal. That is actually ideal. Really like that. Okay, so we can move around. And yeah, nice. Okay, so maybe we can now factor out all of these things into their own entities, because look at that. You have entity position, you have entity direction. You can essentially maybe factor that out. Who said you can't do that? Right, so yeah. So you can have something like interface entity, right? Interface entity, and basically it has a position and direction. Position, and it's going to be number. And direction is going to be number as well, right? So position and the number. I think player actually conforms to this thing, right? So it has a position and it has a direction, right? So that means I will be able to pass, if there is a function that accepts entity, I will be able to pass player there as well, right? So that's kind of nice. So you can have this kind of stuff. So maybe we can factor this entire thing out into a separate function. Not really sure how to call that. So let's call it I don't know, it's called foo. So here we have an entity one, right? So maybe let's call it a player, right? So it's going to be entity and entity, right? So something like entity. So like player is an entity because the player interface can be passed in here, right? So because entity is sort of like a subset of the player. And in here we're supposed to return a number. On top of that, we want to actually provide the sprite count, right? So it's more like a sprite count. Though for all of the, we're always going to have 8 sprites anyway, so I don't really plan to have more angles for the entities, to be fair. Right, so I think 8 is going to be sort of like a standard. All right, so I think 8 is going to be sort of like a standard. Okay, so now what we have in here, so we probably want to return the whole thing. So entity direction, so then so entity position, so it's this position and we're subtracting the player's position. Yeah, so maybe it would make sense to actually factor out 8. All right, so how can we call it? Sprite angles count is going to be 8, right? So sprite angles count, and 8 in here, I don't know, I think we can just hard code this entire stuff. Right, so sprite angle index, that's a good name. That's a good name, chat. Actually, good name. So let's create an entity. And that entity is going to have this specific position. Right, so it's going to have this specific position, this specific direction. So that's pretty cool. That's the entity. And as an index, we're going to do the following thing. So let me grab this entire function. Let's grab this entire function and put it in here. That's cool. So the player is game player. So does it work? Yeah, it does work, because again, player is just like a super interface of entity. And an entity in here is just that. So, and then we have to provide the entity position. Well, it complains about something in here. It's not a Motherflipper, no, like I thought I understand how the type system of TypeScript works. Apparently I do not. So, добрый день. Добрый день, братья славяне. It's kind of funny how like Slavs, pretty much any Slav can understand what I just said. So for any Slav, it's just like, I think I used all the Slavic words, right? It's like an inter-Slavic thing. Bratislavian indeed, yeah. Добрый вечер. День, вечер. All the Slavic words, So entity position. Okay, so how can I fucking fix that, my friend? I can explicitly say that player extends the entity interface. Is that a good idea, chat? Is that a good idea? What do you think? Right. It's like extends. So extends entity. Makes sense to me. Fuck. Okay, that explains. Okay, so it doesn't have to extend it. Thank you. All right. So now it works. So it means I did in fact understand how this thing works. I did in fact understand. Okay, so that's pretty cool. Now, what can I do in here? That's very cool. I can even factor that shit out further. Right, for example, if I want to have several entities, right. So we can do something like render entity. Let's call it render enemy, right? So render enemy. And here enemy is an entity, and it has a certain position and stuff like that. So I can now, oh yeah, this one is very interesting. So that means we'll have to pass the player to actually render it properly. Yeah, so we'll have to pass the sprite pool. Let's actually pass the entirety of the game in here. Right, so we pass the entirety of the game, and here is an enemy, like so. Right, so render enemy entity. So, and now, what that means, I can have two entities, right? So I have entity one, I can create another one, right? So, I don't freaking know. I can create entity two, right? That one, in terms of X, will be placed nearby by X, and looking in an opposite direction, maybe, so mathpy, so 100, and then I can just render this thing. Furthermore, I can move them into array, right? So who said I can't like create an array out of this entire stuff? I can. Right, so I can say entities, right? So this is entities, like so. So, and let's do it like that. There we go. Might as well maybe put additional lines in here. Right, so these are additional lines. So now I can do something like entity of entities, entities, about some entities. So now I can add more and more entities, and they're going to be rendered correctly. Their sprites are going to be actually computed correctly and stuff like that. They're looking at each other. It's a face-off. Oh shit, that's so fucking cool. I love that. Oh my god, they're looking at each other. You can clearly see that. Oh my god, I love that. That's so cool. That's what they're literally looking. And this is not a 3D. Look, this is a pseudo 3D. Right. This is a fucking pseudo 3D. And it makes sense, right? So they're just like looking at each other. So romantic. Yep. Yep, they're looking at each other. Damn, bro. Damn. Make them spin. I could, maybe. So I could just like... okay, so I can just do time. Alright, and that's it. I can make it like spin twice as fast. Yeah. Like this one is looking at this one is just like, what the fuck are you doing? Like, are you okay? It's like me and my brother. Alright, so what about like maybe 16? So they're gonna go brrrr. Are you gonna go brrrr? That's so cool. I really like that. Boom. Damn, can I add more? What if I actually take that one and now I want to add it on y-axis? Alright, so that's another one. So let's make all of them look at that one. So this has to be like a 90 degrees. It's looking in the wrong direction. So what about -1 then? Yeah. So they are observing malfunctioning robots. Why is this so fucking funny? It's just... Can you move it up and down? I wonder if I can specify... Okay, so can I specify the size of the entity, honestly? I think I can. Right, so if I add an additional size in here, it's still part of the interface, right? So let's call it scale, right? So the scale 1. So I feel like I need to introduce like an enemy interface enemy. It extends entity, right? And it just creates a scale. All of that will go away. So this is like a temporary code. So enemy, right. And the reason why I want to have that is because now I want to specify the scale. So the scale is this one. So enemy scale, right? So this is the scale. And here, this is 1. And I want to make it go up and down, we need to make it maybe slightly smaller. Something went wrong, yeah. Oh my god, I love it. Okay, so what if we introduce Z axis for this thing as well? Right, so originally Z for all of these things is 1, right? So this is 1, and let's actually make them 1 and 1. Okay, so now I can do something like enemy Z, right? So is it working? Okay. By the way, I think I need to bring back the angle of the player, the initial angle of the player, because this is a little bit annoying. What was the initial angle of the player? Does anybody remember? Yeah, here it is. This is where I did the modification. Okay, that's cool. So now, chat. So what we want to do, we actually want to move from 0 to 1, right? So let's actually move from 0 to 1. So if you have sine over time, you actually move from -1 to 1, right? So which is not what we want. If we add 1, we move from 0 to 2. So we offset -1 to 1 to 0 to. But this is not what we want. We want to actually move from 0 to 1. So we divide it by that. So, and that will make it move like from 0 to 1, but I think it will go actually below the below the floor, right? But we can fix that a little bit later. So okay, so that's working, and it actually goes below the floor, as you can see, right? So, and it needs to be as fast as it's rotating, so we have to multiply by 16. Maybe this 16 has to be the factor. Let's call it something like a crazy factor. Crazy factor 16, right? So, and let's actually do it like that. Crazy hamburger. So something like that. So, and maybe we have to calm it down a little bit. So how about 10? Yeah, didn't I save it? Yeah. Yeah, that's a little bit better. So yeah, we need to actually limit the whole thing. So how can I lerp from actually half? Oh, I see. So we need to multiply it by half. So now it's from 0 to half, but then we have to offset it by half. So it's from half to 1, and that way it is not going to, yeah, there we go. As you can see, it's just like jumping around. Crazy hamburger. All right, that's actually cute. This is so funny. I love that. I fucking love that. So as you can see, we can. It's like a child and parents. So this is the scale. But what we want to do actually, I think, is maybe factor out the scale to here, right? So now this is the scale. So I can even do it like that, right? So this is the scale, and the offset is the scale. So, but here, this has to be sort of like a 1 minus scale. Yeah, it has to be 1 minus scale. Yep. Yeah. So that will allow me to maybe make it a little bit bigger. Right, so let's go. So now it's a little bit bigger. Yeah. Love it. So there's a bomb here, right? So maybe I want to offset that bomb a little bit. So create the game. Where is the bomb position? So in terms of like, I think it's X. So if I put it like 3, right? Where is it now? Yeah, so that's a little better. So that's going to be the scene for now. That's going to be the scene. So I suppose we can say that we successfully implemented the, mapping of the direction of the entity and the direction of the player to the corresponding sprite. So this system seems to be working really nicely. I really like how it works. So yeah, that's perfect. By the way, and maybe the entities have to be actually slightly smaller than 1, and that will enable us to actually have jump like this, for instance, because that's kind of cool, right? So being able to jump and shit. Look at them. This is like, what? All right. So let's do a commit. Let's do a commit. What we're gonna say in here, chats? What we're gonna say? What we're gonna say now? What we're gonna say? What we're gonna say now? Right. Stay away. Yeah, exactly. This is like, it's none of your business. Stay away. It's none of your fucking business. It's only between us. Stay away. Don't. Fucking don't. Okay. All right. So what was going to be the commit message? I need an AI that does the summary of what I did and then the commit message. So I really feel like Toddy missed his calling for 90s street rap battle beatboxer. He could have done great. Here's the thing about beatboxing. It comes and goes in waves. So 10 years ago, there was a new wave of beatboxing. And this is where I actually joined in and started to learn. So like 10 years ago, beatboxing was like another wave of it. And then it went away. I expect maybe at some point it's gonna get back. So it's constantly like appears and disappears all the time. It's just like people rediscover it, then get bored of it, then forget about it and rediscover it again, right? So I'm not really worried about that. So like beatboxing is actually really cool. It is actually really cool. It's really fun. And I really recommend for anyone to learn it. And there's a lot of tutorials on YouTube. Like literally just go to YouTube and just search like beatbox tutorials. And there's a lot of cool people who can explain you how to do that. So yeah, it's cool because it's an instrument that is always with you, right? It's always with you, so you don't have to bring it with you. It's just like it's there. So if you want to have some fun, you can start doing it right here. So yeah, what we're gonna do in here, implement. So I don't freaking know how to do that. So sprite angle. Okay, implement sprite angle index mapping. Right. Beardy Man. So people know him. Yeah. So Beardy Man was hot not so long ago. I think roughly 10 years ago. Beardy Man is a fucking genius. I'm telling you. He actually kind of revolutionized the whole thing with his setup. So the level of experimentation he did with different like loopers and recorders and effects on the fly is fucking insane. And the fact that he can improvise on the fly is just holy fuck. This person is on a completely different level. Anyway, so I'm gonna push that. And so yeah, we have a way to render entities, render players that look at different directions, which is already enough for us to introduce multiplayer. And this is exactly what we're going to be doing already on the next recreation programming session with Mr. Zozin. So that's it for today. Thanks everyone who's watching right now. I really appreciate that. Thank you for all of the subs, resubs, recommitments and stuff like that. Let's actually take a look at them. So Torgo7, thank you so much. And Young202, thank you so much for your one with the message. Yo, bro, yo. What was the Astra Fuffles? Thank you so much for the Prime Crawl 161. Thank you so much. Rodgo Mesk, thank you so much for resubs and gifted subs. Thank you. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on next recreational programming session with Mr. Associate.